Dobar dan svima, nadam se da ste svi ok. Ajde da upoznamo doktora Antonija Purcella. Doktor Tony, kako se sam predstavlja, je završio, diplomirao matematiku 1990. godine, a doktorat iz geofizike stekao je 1997. godine. Zašto pominjem doktora Tonija? Pominjem ga zato što je pre nekoliko dana imao javnu diskusiju na YouTube-u sa jednim ravnozemljašem koji dobro poznaje naučni metod i kako se eksperimenti vrše u skladu sa naučnim metodom. Reč je bilo o gravitaciji i korišćenju gravitacije za istraživanje minerala u zemlji. Ajmo da pogledamo kako je taj intervju, to jest diskusija, protekla. Izvolite.
Just one sec. I just want to welcome Tony Purcell to the channel, the PhD gentleman I was talking about. Tony, do you just want to quickly introduce yourself to Spurs and tell him what it is you do?
Hi Spurs, I'm a research geophysicist, so what I do is I model Earth's gravitational field and shape as a function of time, and I model satellite orbits and their response to mass distributions on Earth's surface and within the Earth.
Okay, nice to meet you. Nice to meet you.
Cool.
Nice to meet you.
We'll get to your questions that you had for Spurs in a minute, Tony. We'll just let Brainy finish the discussion he's having with you.
Okay, so Spurs.
Hi.
Do you understand that mineral exploration is something that receives a great deal of funding?
Mineral?
Mineral
mineral?
exploration, yes. Yes, minerals.
Okay.
Okay, so a lot of effort is put into developing techniques to try and work out the location of ore bodies underneath the Earth's surface. Obviously, we can't see them, and drilling holes to work out whether or not they're there is expensive. So the ideal solution is to have some sort of observation that we can perform at the surface that will tell us where there's dense material that probably corresponds to ore bodies. Okay?
Okay. Yeah.
All right. So one of the ones that you're probably very familiar with is seismological. There's another one that's called magnetotelluric mineral exploration that relies on the conductivity of the material. So you generate an electrical field, you look at sort of the return electrical field that results in Earth's interior, and then you can sort of work out where conductive material is. But the third one is gravimetric mineral exploration. And the way that works is that we have what are called gravimeters. They're devices that basically measure the extension of a spring that has a test mass on it. And as you move this around, the extension of the spring changes. Okay, there's more force applied. Well, there's more force applied at some points on Earth's surface than at other points on Earth's surface on this test mass. Now, those are the observations. What we do then is we hypothesize that those apparent changes in force are the result of density distributions underneath Earth's surface. And we invert the observations to work out where the density perturbations are and how big they are. And this technique is accurate enough that we can locate subsurface ore bodies. Now, if your theory, if your suggestion that Newtonian gravity is just wrong, that it doesn't work, my question to you is, why does that technique function at all?
Well, you're implying that Newtonian is a pulling force. Is that what you're suggesting?
I am demonstrating that Newtonian gravity is a pulling force, and it is observable.
Okay, so how does that work?
Because if it weren't, I don't need to explain the mechanism in order to observe it.
Yeah,
Just
I mean,
like
'cause
you
you
don't
have,
need to. You
what, hold
don't
on a
need to.
second. Excuse me, sir. What's your name again, sorry?
My name is Tony.
Tony, okay. It's chemo, Spurs chemo. So, yeah,
Yep.
again, if in nature we have an observation, we have a phenomena, you then obviously would have a hypothesis, yeah? So you're saying because...
But I have observations to start with, right?
Okay, yeah, so what did you observe? What was your observed phenomena here?
I was observing the extension of a spring which depends a reference mass as a function
No,
of
no, hold on.
location. I
Sorry,
was
sir.
doing it.
So an observed phenomena is something that comes into question, right? So it's questionable, something that you don't quite understand. So what did you see in nature that was
No,
questionable?
I
That you didn't...
reject that. I reject that characterization completely. You cannot tell me how I have to view things philosophically in order to conduct science.
Well, this is what I'm
You
asking.
don't get
First of
to.
all, what is the question? What is the question you're asking here?
The question I am asking is, can I use variations in gravitational acceleration to...
Sir, you're presupposing gravity already. I'm asking you about the phenomena in nature that you saw, that you questioned. What did you see in nature, in the natural and physical world?
I saw variations in the acceleration that objects experience as a function of location.
So you saw something move quicker in one location than another
I
location.
saw it accelerate at a different rate.
Okay. So what are you hypothesizing? What's your predicted cause of this
My
change, this phenomenon?
hypothesis is that that's due to differential density perturbations underneath Earth's surface.
That's your predicted cause to this effect?
Yes.
Okay, so how have you tested this, sir?
I test by drilling in areas where my observations of the variations in acceleration.
Sir, you have a cause to this effect. This would be your independent variable, right? So what do you predict is the variable that caused this?
I'm sorry, I'm going to have to appeal to the other participants in this conversation. I feel I've explained this 3 times already. How do you now, and I feel you're being willfully obtuse in choosing not to understand what I'm saying.
Yeah,
I still want to know how you know something then. How did you come to the conclusion without testing the cause to the effect? Did you guess?
Okay, I did. So let me explain to you how the scientific method works. Okay, there's a phenomenon that you observe. In this case, it's extension of the spring from which the mass depends. Okay, we develop a hypothesis as to why that might be occurring, and we say, okay, if that hypothesis is correct, then we would expect this. Okay, and then we go and test that and see whether or not we were right. Okay.
Right about what, sir? But right about what? What's the question?
Right about
what are you asking?
Our hypothesis.
What was the question, sir?
Kimo, he's just saying this is how it works in general. He's
yes,
not
but
talking
I'm
about
saying
a specific
that why
thing.
would you come up with a what is the question?
The hypothesis is the question. They are testing to see if the hypothesis is
Okay,
correct.
so my question is, why is the spring different extent? Why does the spring experience different forces at different points on Earth's surface?
Why does it experience different forces? So there is a cause to why this happens. What is that cause?
That's the purpose of the experiment.
Okay, that's what we're doing. That's correct, sir. So that's why we don't know what the cause to why there are different, if they spring.
I'm going to interrupt you there. I'm going to interrupt you there.
Sorry.
Because of the people in this conversation, I am the one with the academic qualifications who is published in a peer-reviewed journal and who is employed as a professional scientist. So any assertion that you make, like that's correct, or
Sir, I am merely been a
so
student
on,
asking
you
questions,
are,
sir.
no. You are attempting to arrogate to yourself an authority that you do not have.
Sir,
Please
you are the
desist
authority.
from that sort
You
of
are the
assertion.
expert, sir. I am asking you merely a question. What was the predicted cause to the effect, sir?
Okay, the predicted cause to the effect, as I have stated 4 times now, is non-uniform density distributions underneath Earth's surface.
So the predicted cause is non-uniform, non-uniform.
The gravitational attraction due to non-uniform density distribution underneath Earth's surface.
Okay, so how did you manipulate your cause, sir?
Going to different places on Earth?
Yes.
Right, Schemo, the question
So,
you're asking...
Craig,
one sec. The question you're asking is what is the independent variable,
We're asking the professor here. So, how did you
clarify your question. Your
How did you manipulate your predicted cause, sir?
One sec. Your question is what is the independent variable, right? That's what you're asking.
We know the independent variable. He's just told us. And I'm asking him now, how did he manipulate his independent variable, sir? Remember, we are just we are merely but the students.
He's
and
literally
the authority
told you
here.
about 4 times by going to different places on Earth.
You said, Craig, you told us. I didn't hear anything from the professor here.
Okay, so we take different measurements at different. We take measurements of the extension of the spring at different points on Earth's surface and at different altitudes.
Is that acceptable?
This gives us an array of. This gives us an array of points. We can also
so we
make
have an
observations
effect, sir, and you're saying that you took different measurements, and that was the cause to the effect was you taking different measurements, all the different.
No,
Sorry, sir.
No, that's not what I said at all.
Okay, so I'm rather confused, sir. So we have a cause. We have an effect. Sorry, we have an effect. Sorry, we have an effect. We have an effect. Sorry. I'm trying to explore the.
No. What you are trying to suggest is because what you are trying to say is that you will only accept this experiment if I can turn on mass distributions under the Earth or turn them off. Now, I can test this methodology. I can do the test that you're suggesting. For instance, I can go into a field, bury a large test mass at a point in the field, and send students out with a gravimeter and say, find the test mass, or tell me if there's a test mass in there in the field, and if there is, where it is. So I can do controlled experiments. But what I was referring to, I can do controlled experiments where I know what the test mass is and where the test mass is. But having confirmed my...
Sorry, sir. Well, I mean, just to make this simple, this is why it's just a very simple process. Yeah, a few steps. So you're saying that you observe the phenomena, and we have an effect. It would be your independent variable. That would be your dependent variable, sorry. So we're looking for the cause to this effect, sir. Just the cause, so we can manipulate it and find out why this happened.
Yep.
And he's already explained that.
By taking measurements, he said.
Yeah. And then
that's the cause
he also explained that they can drill in the particular areas that they are to check the density distribution to confirm the cause of the effect.
Yeah, what is the cause? What's the name of the cause?
Let me take a step back. The cause of the difference in the extension of the spring is different gravitational forces, different gravitational acceleration experienced at different points on and near Earth's surface. Now, here's the thing. You're trying to argue that this entire theoretical field is invalid, that it doesn't obey the principles of observational science. You're attempting to argue that I haven't, that this entire
Sir, I've made
field
no such claim, sir. Please don't put thoughts and words into my mouth. I merely asked you simple questions that you hadn't observed phenomena in nature. I asked you for the cause to the effect, sir, and now you're berated me for something I haven't said about you when I've asked you very simple questions, sir. Why are you attacking me?
Victim card for 500 pop.
Yeah, Jesus.
I don't feel that I have attacked you.
So can we talk about science, sir? I would rather
surmising-
talk about science, and I would rather talk about
Okay,
effects and
now I
cause.
shall attack you because that was an idiotic statement to make.
What, sir?
He's right.
That was idiotic and intellectually dishonest. We have been discussing science the entire time.
No, you've just told me I
And your
don't want to do
suggestion-
this, I don't want to do that, I don't want to do this. When all I asked you, sir, what was the cause to the effect? That's it.
And I have explained that 5 separate times.
I think it's 6.
And then
And
I
I'm
asked you,
sick
sir,
and tired.
how did you manipulate
Yeah.
your independent variable? And you didn't answer, sir. How
Yes, he
did you
did.
manipulate
Yes,
it?
I did.
So you manipulated by going to different places.
No, you buffoon. I can test it I can test this technique by going into a field and burying test weights in it. And then I can use the methodology I am suggesting is accurate to locate those test objects, taking measurements in different locations.
So the cause is what?
The
Conclusion,
cause is the masses that I have buried in the ground.
So the masses that you put in the ground cause the effect that we see in nature, sir?
No. They
Okay.
cause the effect that is detected in the experiment that I am undertaking. I can
Okay.
then use the results from the experiment to analyze observations in nature, to
So
detect
different-
natural ore bodies and density anomalies. And I can do so accurately when I extend my technique this way.
Okay, sir. I mean, I don't think you're quite following the scientific method here, but
Then,
Oh my God!
then-
He's a
Which is
scientist!
exactly what I just said you would say.
Yep.
I
well,
said,
so you did not. You didn't give
I
me
said
your.
several
depend-
minutes. No, shut up. You know, I said you were working towards this argument, and you said, no, I'm not. I'm just asking questions. And then, 3 minutes later, you're out with this bullshit.
I said I don't think so, sir.
Now, yes. And how would you know? Why would you, why would you have any worthwhile opinion on this?
Well, I mean, I think science is for everybody, sir. I think if there's
No,
a
it
method that
isn't.
you can.
No, it isn't. It's for people who are. It's for people who are appropriately qualified and knowledgeable. The idea that it's some sort of democratic process that everybody gets to participate in equally is false.
Yeah,
It's
Spurs,
just a false notion.
quick question, Spurs. How many
So,
PhDs
are you
do you
saying,
hold?
sir, that not
one
everyone
sec,
can do
Spurs,
science?
1 sec. How many PhDs do you hold?
Yes, that's what I'm saying.
It's not about me, Craig.
No, seriously, how many PhDs do you hold?
No, seriously, it's not about me.
So can we say less than 1?
It's not about me, Craig.
Right, okay, so this guy has a PhD
Yes, it
in
is.
science, so he is the one that gets to tell you about the scientific method and not the
Which
other way
is-
round. Do you understand?
Which he's doing so, Craig.
No,
He's
then
doing
you're going,
it.
no, then you said, excuse me, sir, no, that you're not using the scientific method. You do not get to tell an actual scientist with a PhD in his field how to apply the scientific method. He gets to tell your ignorant ass how to do it. Do you understand?
And
let me make another.
He's been telling you.
Let me make another. Let me make another. Let me make another point. This field of scientific endeavor is used by mineral companies who invest a significant amount of money in it to locate ore bodies. Now, if it was inaccurate, unreliable, unrealistic, unscientific, that would not happen. So, observable reality is that this field of gravimetric mineral exploration produces valuable real-world results. Earth doesn't. It's that simple.
Okay, I mean, again, I would definitely question, your methods, sir.
Under what authority do you question his methods?
Well, again, under the scientific method, which is for all.
No, it isn't.
It's for scientists.
No, it's not. So, look, you've already admitted that you don't have any formal training in science.
No, I said it's not about me, sir.
So you admit.
So you don't. So, if you, God forbid, I hope this never happens. If you suffered a serious medical complaint,
he really does.
Would you come to the conclusion that medicine is something that can be done by anybody? That it doesn't really matter. Any Burke on the street can who's watched a few.
Absolutely not.
I was going to say, you're asking somebody who's probably going to take like red clover
Absolutely
or something
not,
to
sir.
fix it.
That
Continue
would
forward.
Be completely
Okay.
ridiculous, sir.
Okay, so
my bad,
so
sorry.
you understand the value of technical expertise in a field, and you concede it.
Well, I mean, I think one of the main reasons why we trust the professionals in that field is because they are doing actual physical, practical work there, sir. Whereas what you're describing,
just like the gravimetric mineral explorations are doing tangible, real work in the real world.
But yeah, sir, again, I respect that you're going out there doing work, but finding the cause to the effects without a scientific experiment is not going to give you a conclusion. And that's all we're looking
You
for.
are asserting that you are asserting that it's not a scientific experiment, and you are wrong to do so.
Well, I did ask you. I did go through the steps with you, and what we've concluded is that you've moved from one place.
Again, you are arrogating to yourself the ability to discriminate between what is science and what is not science without any technical understanding of what science involves.
Well, science, it deploys observations in the natural and physical world, and then obviously testing with an experiment.
Zbog čega je naučnik Toni bio toliko iziritiran u toku ove diskusije i zbog čega se toliko nervirao da je čak koristio i ružne reči, verovatno je uzrok tome njegovo samo spoznanje da o naučnom metodu ne zna ništa. Također ne zna ništa ni o tome kako se eksperimenti rade po naučnom metodu. Da sad ne bih dužio puno o tome, onaj ko nije pogledao, neka pogleda moj video koji sam napravio o naučnom metodu i o eksperimentima koji su u skladu sa naučnom metodom, a link će biti u opisu ovog videa. Samo ukratko, znači, onaj ko želi da radi eksperimente koji su u skladu sa naukom i naučnim metodom, mora da zna da uzrok nečega mora da utiče na posledicu, to jest na pojavu koju posmatramo. I taj uzrok, ta nezavisna promenljiva, se mora se znači s njom manipulisati, mora se menjati da bi izazvali promenu zavisne promenljive, to jest pojave koju posmatramo. U suprotnom, ne možemo nikad biti sigurni da je to uzrok onoga što posmatramo. Tako da to je to za danas. Hvala na gledanju, ostavite komentare i veliki pozdrav!